So we're going to start here. So again, simplifying is really just a whole lot of factoring, simplifying down. We factor, see what's in common, simplify out. Now, there was one similar to this here. I think it said a is equal to 2x squared plus 4x plus 14, and b is equal to 2x, not 2x. 4x plus 8, which of the following is equivalent to a over b? Because it was 2, that should have been 8. This is probably minus. I think it looks something like this here. Then it's really just saying what's 2x squared minus 8x plus 8 over 4x plus 8. Simplify and solve. Now, the other thing that's interesting, especially if it says which of the following is equivalent, which of the following statements is equivalent. Equivalent means equal. They're the same, yes? So that means I could pick a value for x. As long as it doesn't make the denominator be 0, I could say x is 0. So this here would be 2 times 0 squared minus 8 times 0 plus 8 all over 4 times 0 plus 8. It's not telling me to evaluate. It's not telling me a specific value. But if they're equivalent, they have to be equal, yes? So if I said x is 0, we did this here. We end up getting 8 over 8 or. Then for each of the answer choices, I can plug 0 in for x. Whichever one has the same value is equivalent. So we didn't actually have to do any simplifying. We would just plug a value in and solve. I mean, we could do the same thing here if it actually gave us 4 answer choices. Again, that's one of the reasons I don't like multiple choice on a test, because we can do something like that and it will give us the answer. Or we do 2 steps in and we have the answer. Now, when factoring this, we need to factor the top and bottom. We're going to need to do both, but whichever one we see the factors of first is where I would start. X squared minus 9. There is no greatest common factor between the two. We have 2 terms being subtracted, yes? X squared is a perfect square. It's x and x. Is there a number multiplied by itself that gives us 9? 3. So it's a difference of perfect squares. Telling us we have x plus 3 times x minus 3, yes? So that's going to be part of our answer. Either one of these two. Now, we have to factor the top to see if there's something in common. If there is, it's going to simplify out. If there's not, we're just going to leave it as is. Now, x squared minus x minus 12. There's no greatest common factor between the 3. Since the third term is negative, our signs are opposite, plus and minus. Now, our factors of x squared, only one set x and x, yes? Factors of 12. 1 and 12, 3 and 4. Is there a high likelihood that 2 and 6 would work? Probably not, because if 2 and 6 were the correct answers, it was x plus 2 times x minus 6. Is there anything in common on top and bottom? No. So it won't reduce, it won't simplify. And if this was it, it's not. But if it was, leave it here. Nothing simplified as simplified as it gets. Because the only other option is to multiply it back out, which just gets us back to where we started with. There's no reason to backtrack. It's just simplified here. So if that is it, it simplifies, leave it here. I will tell you this now, I will see at least one of them That will break it down into partial fraction decomposition, give me 3 fractions that are being either added or subtracted to each other. I will know immediately that's been looked up. For one main reason, partial fraction decomposition is not covered till pre-calc. So, if it simplifies, there's nothing that factors out, nothing simplifies out, leave it. Leave it as the 2 fractions on 2 sets of factors on top and bottom. But most likely, we're going to want 3 and 4. Now, where do you want to put the 3, plus or minus? Plus. 4 is minus. This works because x plus 3 over x plus 3, those are the same. They will simplify out if these are the correct factors. Same thing's true with the minus. At this point here, we can check x times negative 4, negative 4x. 3 times x is going to be plus 3x. Negative 4x plus 3x does indeed give us the negative x middle term we want. So it's going to be the one that cancels out. Because now, just like before, just like we did the other day, we could split that x plus 3 over x plus 3. It's just 1 fraction multiplied by the x minus 4 over x minus 3. X plus 3 over x plus 3 simplifies to 1, leaving us with x minus 4 over x minus 3. Now we can't simplify that any further because those are stuck together, those are stuck together. That's just simplified as it gets. Questions on this here? Really, by this point, especially the step above it where we see what's in common on the ACT, we would have had the answer by this point. We know it cancels out. It can't just magically flip and be x minus 4 over, or x minus 3 over x minus 4. We have our choice. Restrictions. Well, the 2 places that x can be 0 can cause a division of 0 is x plus 3 and x minus 3. Those are our 2 factors on bottom. Those are the 2 values of x that would make the function be, or 2 places it can make this expression be 0. Now with our x plus 3 to solve, to see what value of x will make it be 0, we can subtract 3 from both sides, telling us if x is negative 3, it would cause the denominator to be 0, so we cannot have x being negative 3. With x minus 3, we'll do a similar thing, but we won't subtract 3, we're going to add 3. So our negative 3 plus 3 would be 0, giving us x is equal to 3. Telling us if we have a value of x or x is 3, it would cause a division of 0, so x cannot be 3. Questions on this here? That also means the method I started out with showing where we can plug a value of x in and simplify. What are 2 values we cannot use? 3 and negative 3. Because if we plug it in, the calculator is going to tell us error dim 0 or division of 0, div 0 error, divided by 0 error. If you get that, especially with doing those, pick a different number. Try again. Because if the first one gives it for that, the correct answer should also give you that, dividing by 0, or it's going to factor out. I would just pick a different number. Pick a different number, try again. Questions on this here? We ready for the next one? X plus 4 over x squared minus 16. So, we need to figure out what to factor out. Yes, we need to factor it. Now again, we see x squared minus 16 on bottom, yes? 2 terms being subtracted, so it's probably a difference of perfect squares. X squared would be x and x, yes? What would 16 be? What times itself is 16? 4 and 4? Yeah, no, 8 times 2. Yeah, 4 and 4. Mm-hmm. So it would be 1 and 16, 2 and 8, 4 and 4. So 4 and 4 would give us that difference of perfect squares, so we want it. So that's factored. Now we need to look at the top for it to be factored, yes? Well, we have two terms. We have x and 4, yes? Is there a greatest common factor between x and 4? No, there's not a number, there's not a variable in common. Wait a minute, what's the degree of the top? What's the biggest or exponent attached to a variable? So if there's no greatest common factor, that is factored. There's nothing we can do with it. We can't break it up into parentheses. It is factored. And especially, it came up on the test in 3 spots, my factoring test last time. Where we factored it out, we got 2 terms left. They could have been squares. There's nothing else we can do with it. We're done. We don't have to factor to 2 sets of parentheses. Yeah. It's right next to Mr. Matney. Mm-hmm. So there's nothing we can do to the top. Even if there was, well, wait a minute, x plus 4, we have it on top and bottom. Even if it factored simplified further, I have it on top and bottom. I have a like term on top and bottom that will reduce. So would there be any reason to simplify it further? No, because it's already going to reduce out. The x plus 4 on top and the x plus 4 on bottom would cancel. Now we would still have x minus 4 on bottom, yes? What would we have on top? 0 is the tempting answer, yes? It's not 0. 1. Anything divided by itself is 1. Because there's never going to be a time, especially when simplifying, especially essentially we're dividing, where we can divide 2 things and get 0. Especially when the 2 things we're dividing are not 0. Because this is a side note, really what we're saying is that b divided by c is 0. Because we're saying that we have 2 things being divided, give us 0. Well, another way to look at it, to get rid of the fraction, we're saying, what value b? What's v if 0 times whatever c is? That's what we're saying, yes? Well, wait a minute, what's 0 times c? 0, which means b has to be 0, yes? Well, we knew from the start b is not 0. So is there any way this works and gets 0? No. We can't divide 2 non-zero terms and get 0. The only way we can is if the top is 0. But if they're the same, top can't be 0 because then the bottom would be 0. It just doesn't work. When we simplify or divide like terms, it's going to reduce to 1. If it simplifies out completely, it simplifies to 1. Does that make sense? And I have a feeling on the ACT for a problem like this, they would put 0 as an answer. Because they're assuming you're going to put 0 over that and it's just going to reduce to 0. So the 2 places where we could have restrictions, we could have a division of 0 is with x plus 4 and x minus 4, yes? To solve for this here, for x minus 4, we would add 4 to both sides, telling us that if x is positive 4, we'd have a division of 0, so x cannot be 4. With x plus 4, we would subtract 4. 4 minus 4 is 0. Telling us if x is negative 4, we'd have a division of 0. That does not work. Questions on this here? No? We feel good with this? We started to see why I hit factoring again. Factoring shows up time and time again. Now, will there always be restrictions? No. Because again, our restrictions is any value of x that would make the denominator be what? 0, yes? So I'm just going to put this here. You don't have to write this down. If we said x squared plus 6 was the denominator, we don't have a sum of perfect squares, so that's not factorable, so we would leave it there. I'm going to graph it. Because x squared plus 6, the restrictions, especially if it's on the bottom of the fraction, would be any value of x that would make it be 0. If we graphed it, those values of x would be where it crosses the x-axis, yes? Wait, looking at this graph, does it cross the x-axis? Well, no. So that means there's no value of x that will make x squared plus 6 be 0. Which means, especially if that's on the bottom of the fraction, there are no restrictions. There are no values of x that would make it be 0, because there are no values of x that would make the denominator be 0. So not every one of them can have restrictions. If the denominator can't be factored, can't be solved with real numbers, there are no restrictions. All right. We're going to factor this here. X squared minus 2x minus 3 over x squared minus x minus 6. So we have to factor the top and bottom, simplify like terms. Simplify like expressions. Do we want to factor the top or the bottom first? The top. X squared minus 2x minus 3. There are no greatest common factors. There are no common factors between x squared, x, and 3. Since the third term is negative, we know the signs are opposite. One is going to be plus, one is going to be minus. Factors of x squared. The only choice we have is x and x. Factors of 3 are, well, 1 and 3, yes? Where do you want to put the 1? Where do you want to put the 3? 1 there, 3 there. Then off to the side, we can kind of make the check to see if we have the correct middle term. X times negative 3 is negative 3x. Positive 1 times positive x is positive x. Negative 3x plus x would indeed be negative 2x, which is the middle term we wanted. Now we can move to the denominator, the bottom of the fraction. No greatest common factor again. As the third term is negative, the signs are opposite. One's going to be positive, one is going to be negative. Now our factors of x squared are x and x. Factors of 6, 1 and 6, or 2 and 3, 3 and 2. Which one do we want to try? 2 and 3. Now, really, both of them could possibly work. We could get x plus 1 over x plus 1. Or x minus 3 over x minus 3. Because if we pick 2 and 3 for something to simplify, we need to have x minus 3 and x minus 3. We need those to match up. We need those to be the same, so they'll cancel out. Note sheet from Tuesday. Mm-hmm. Now we can check this here and make sure. X times negative 3 is negative 3x. Positive 2 times positive x is positive 2x. Negative 3x plus 2x, negative 3 plus 2 would give us negative x. So those are indeed the correct factors. But since we know that's there, we do have a greatest common factor, or common factor on top and bottom of x minus 3. And that x minus 3 divided by x minus 3 would divide to give us 1, simplify to 1. So those would simplify out, leaving us with x plus 1 over x plus 2. Questions on this here? Questions on anything we've done so far? Well, We can talk about the restrictions, but again, restrictions, especially for pretty much the rest of even this section, we're not going to talk about it too much, especially with some of our multiplication. We'll talk about it a little bit with the non-monomials. We want to get rid of anything that would cause a division of 0. So x plus 2 would cause the denominator to be 0 if it equals 0. So we can subtract 2 from both sides to solve for x, telling us that if x is equal to negative 2, the denominator would be 0. We cannot have that. We cannot have a division of 0. With x minus 3, we would add 3 to both sides, telling us that if x is equal to positive 3, we'd have a division of 0, and that doesn't work either. So our restrictions would be negative 2 and 3. Questions on this here? Questions on anything we've done so far? Is there one more? Or is... No, I must have added a page at one point, because I think I was helping some of the other classes and added an extra page. Yeah. So multiplying rational expressions. When we multiply two or more or two fractions together, we multiply numerator by numerator, denominator by denominator. Top of the fraction times the top, bottom times the bottom. That's just fractions. We're multiplying. That's all it's saying. And anything that's in common, we cancel out. We simplify out. Okay. So we're going to multiply these two fractions together. Now I'm going to show you two main methods, and then I'll let y'all pick which method we do, because there's been a decent consistency on which method we choose. We're going to look at method 1. Method number 1. Method 1. Method 1 says that we take each of these, the top and bottom of each fraction, and rewrite them in prime factorization. So we get them down as simplified as possible of like terms. So what that means for us, so we're going to start with 8. 8's prime factorization is 2 times 2 times 2. 2 to the third is 8, so the prime factorization would be 2 times 2 times 2. Because 2 times itself 3 times is 8, we could do the factor tree, get there. Y to the third, well, that's telling us x is being multiplied by itself how many times? 3, so we're going to write x being multiplied x times x times x, because there's 3 of them. That's what cubic means. We have this here. And then we just have one y, so we have y. Questions on the first numerator? We'll look at its denominator before moving to the next fraction. Well, the number on bottom is 2. 2 is prime, that's all we have. X, we have 1x, so it's just x. And y squared would just be y times y. So that's prime factorization. We've simplified it into its simplest terms being multiplied together. Our second fraction, 7, is prime. So it's just 7. No way to write it simpler. It is a prime number, so it is its prime factorization. X to the fourth. Well, that tells me we're multiplying x by itself 4 times. So we're going to write x 4 times. Because x times x times x times x is x to the fourth, yes? Y cubed tells me that I'm multiplying y by itself 3 times. On bottom, 4y, well, 4 is just 2 times 2, and then we have it multiplied by y. Okay, so we pretty much, so the first main step with method 1 is we rewrite it into its simplest terms. Then what we're going to do is we're going to multiply them together. So we're going to put all the numbers, so 2 times 2 times 2 times 7 out front. Move them all to the front, they're being multiplied together. I wouldn't necessarily multiply them at this point. We're not supposed to, we're just kind of listing them out front. Now the first fraction, the top of it, has x being multiplied by itself 3 times. The second one has it 4. So we have 1, 2, 3, 4, 5, 6, 7. Yeah. Then we do the same thing with y. We have 1 in the first, 3 in the second, giving us a total of 4. Now the bottom of the fraction is a little bit nicer. We only have 3 2's being multiplied together for our numbers. In both of them, x only shows up once. Then we have 2 y's from the first, 1 y from the second. Questions on how we got to this here? Now we're going to simplify. Well, this first 2 on top, I didn't mean to simplify that far. Over our first 2 on bottom, well, 2 divided by 2 is 1. It would simplify, yes. The second 2 on top would simplify with the second 2 on. Third 2 on top, third 2 on bottom. They are the same factors, so they would divide by them each other to simplify to 1, yes? Under that same method, one of the x's on bottom would divide by one of the x's on top to become 1, yes? Well, wait a minute. What about our y's? We have 3 on bottom. We'll simplify with 3 of them on top. So we can say these 3 simplify with these 3. So let's see what's left. Is there anything left in the bottom of the fraction? No, so it's going to reduce to 1. Do we have to write a number over 1? No, it's understood. So we're really just looking at the top of the fraction. We do have 7 times x. Well, how many x's do we have? 1, 2, 3, 4, 5. So that would just be x to the 6th. We have 1 y, so it is just y to the first of y. So this multiplies together, back together to give us 7x to the 6th y. Questions on this here? We're ready for method 2. So method 2, we're just going to go on and multiply together. Now, we're not necessarily going to multiply, but I want to put the constant terms or the like terms next to each other. So our numbers that we're going to multiply on top are going to be 8 and 7. So we will multiply those together. I'm going to put them next to each other for now. So 8 and 7 we will be multiplying together. We also have x to the 3rd and x to the 4th. They are like terms that will need to be multiplied together, so we're going to be multiplying the x to the 3rd and x to the 4th together. Then lastly on top we have y and y to the 3rd. So we'd have y times y to the 3rd on top. Now on bottom, our 2 numbers are 2 and 4. We will have to multiply those together. Times. Well, the first denominator has x. The second denominator doesn't have any x's, so we just have times x. Now we can do the y's. One of them is y squared. The other is just y. Yes? Questions on how we got here? All right. Now, we can't plug the whole thing into the calculator because we do not have a value for x or a value for y. But our number is 8 times 7. Did we plug that in? Yeah, 8 times 7 is what? 56. Denominator 2 times 4 is? Oh, wait. Wait. Could I have done 8 times 7 over 2 times 4? Because they're just numbers. The calculator will simplify it for us. When we multiply like bases, we're going to look at the variables. X to the third times x to the fourth. When we multiply like bases, we add the exponents. Because I have 3 of them, and I have 4 of them. So 3 plus 4 is 7. So x to the third times x to the fourth would be x to the 7th. Y times y to the third. Well, it's just y to the first times y to the third. 3 plus 1 is 4. So y to the third times y would be y to the fourth. On bottom, our variables, well, I just have a singular x. It's not being multiplied with anything, so it's just x. Y squared times y, 2 plus 1 is 3, telling me I have y to the third. Questions on this here. Now, when we multiply like bases, we add the exponents. When we divide like bases, we're going to subtract. Now, the main method for this here, and the definition of it, says that a to the b over a to the c is equal to a to the b minus c. And it moves it to the top of the fraction. Then if that's negative, if we have negative exponent, we have to move it from the top to the bottom to fix the sign error. I look at it a little bit differently. I don't subtract top minus bottom every single time. I look at the two numbers and subtract them. So if we look at the first, so we'll deal with the numbers here in a second, we kind of already did. X to the 7 over x are like bases. Really, it's x to the 7 over x to the first, yes? So we subtract the exponent. 7 minus 1 is what? 6, yes? Is the exponent bigger on top or on bottom? On top. If it's bigger on top, it stays on top. If it's bigger on bottom, it's going to stay on bottom. That way, I don't have to worry about the sign error. I don't have to worry about fixing it, moving everything to the top, and then moving everything back down that has a negative exponent. 7 minus 1 is 6, and since it's bigger on top, it will stay on top. Y to the fourth over y to the third. Well, 4 minus 3 is 1. Since it's bigger on top, it'll stay on top. And we said 56 over 8 is 7, yes? Well, now we have the fraction line, yes? There's an easy way to fix that. We just say we boxed it. Because there's no denominator left, it would just be 1. We don't have to write a denominator of 1. We just have this here. Questions? Method 1 or method 2? Method 2 is a lot better, especially since we know our properties of exponents. We know how to simplify. We don't need to write it all back out to show that that method still works. Six x squared y over 3xy cubed times 9x to the fifth y squared over 2y. So for multiplying these together, we know we're going to have to multiply the 6 and 9 on top together. On bottom, our numbers, we know we're going to have to multiply the 3 and 2, yes? On top, our variables, we're going to have to multiply x squared with our x to the fifth. On bottom, there's only one x. Nothing we can do with that. Our y's on top, we have y squared and y, so that we know that those are going to have to multiply together, y and y squared. On bottom, we're going to have to multiply our y cubed and y to the first. And 6 times 9 is indeed 54. 3 times 2 is 6. X squared times x to the fifth. 2 plus 5 is 7. On bottom, the x is just going to be x, yes? Our y is on top. Y times y squared, which would be y cubed, y to the third. On bottom, y cubed times y would be y to the fourth. So even if we got to this point here, we know that the number 54 over 6 is, we're going to end up with a bigger number on top, smaller number on bottom, yes? So any answer choice that has a bigger number on bottom is not going to be it. We don't have any other operations. There's no way that it's just going to flip. So we know that any that reduces to a bigger number on bottom or has a bigger number on bottom as the answer choice is out, not it. But 54 divided by 6, 50 over 4 over 6 is 9. Oh, wait. Let me get a highlighter. On bottom, we have 3 times 2, yes? Which is? So that's 6, and the 6 on top, we could have just crossed them out because they are the same, yes? Because again, anything divided by itself is 1. Now, x to the 7th over x. 7 minus 1 is 6. Since it's bigger on top, it will stay on top. Y to the third over y to the fourth. Well, if we did this the proper way, we would say that this is y to the 3 minus 4, which would be y to the negative 1, which to make that exponent positive, we got to move it from the top of the fraction to the bottom. Or y to the third over y to the fourth, 4 minus 3. 4 minus 3 is 1. I did flip the order, yes? But again, if it's bigger on top, it stays on top. If it's bigger on bottom, it stays on. So 4 minus 3 is 1, telling me that the exponent is going to reduce to 1. And since it's bigger on bottom, that y will stay on bottom. To get the exact same spot, I think it's a little bit easier to work with. We're not worried about the negatives or how to rewrite it, move it to the top. Oh, it's negative, move it to the bottom. 4 minus 3 is 1. Bigger on bottom stays on bottom. Bigger on top stays on top. Because we removed 3 from the top and bottom, there was 4 on bottom, so that stays. We haven't mentioned it on these last few, but the restrictions would just tell me that x is not equal to 0 and y is not equal to 0. There are more things multiplied together to equal 0. One of them has to be 0. So either x is 0 or y is 0. This is the last one we'll do before, and then we'll finish this tomorrow. How do we feel about these? Do you feel pretty good? Is there anything that says I have to rewrite it out so that we have 3 times 6? What is 3 times 6? 18, yeah? X to the fifth times x, or x to the first. 5 plus 1 is 6. Y squared times y squared. 5 to the fourth. 2 plus 2 is 4. If writing it out so that we have 3 times 6 times x to the fifth times x times y squared, if that helps keep track of everything and get you to the right spot, do that. If you can make this jump from here to here, do it that way. Do it the way that helps you get to the right answer. On bottom, we have 8 times 9, which is 72. 8 times 9, 72. X times x to the third would be x to the fourth, and y times y is y. Well, 18 and 72. 18 is definitely smaller than 72, so there's a good chance, however that reduces, we're going to have a number on bottom. 18 might reduce completely, it might not, but we know we will for sure have a number on bottom. $18 over 72 is 1/4, so we do have 4 on bottom. X to the 6 over x to the 4th. When we divide like bases, we subtract the exponents, so 6 minus 4 is 2. Since it's bigger on top, it will stay on. Y to the 4th over y squared. 4 minus 2 is 2. Since it's bigger on top, it'll stay on. Telling us it's x squared y squared over 4. X and y can't be 0. But that is it for today. We'll